Yeah. I hope it is visible.
Yes, ma'am. Screen is visible. Yes, ma'am.
Right. Yeah. Good evening, all. I was also listening Dr. Jimmy Thomas' session. So, of course, this will be a continuation of that because I am also going to speak about innovative materials in different applications of geotechnical engineering. So the topic was defined as the slope stability. I'm a little redefining it as landslide and rockfall mitigation systems, as I felt that that may be quite interesting because those are special slope instability problems, isn't it? So we will see the slope stability, how in especially in situations, critical situations or disastrous situations like landslide and rockfall mitigation, how we can deal with a few innovative materials. And these are not, when we are speaking about innovative materials, these are not materials which are just launching in the industry. No, these are in place and almost proven with a number of case studies, and it has come in international and Indian guidelines, but still it is waiting for a wide acceptability, like it need to enter in our, even in our beta curriculum, so that with the steel and concrete the engineers need to understand these materials. So we have already seen in Dr. Jimmy's session the geosynthetics. So I will introduce certain other materials which can go very well with the conventional materials as well as the innovative materials like geosynthetics. So before that, let us see that where the slope stability is uh, prevailing in our country. So it's everywhere. It's every state. There are some critical situation comes as slope instability. Maybe it is relatively small in states like Gujarat, but still I'm remembering a number of projects I was associated, like Sabarmati riverfront development. We had to do the analysis of a slope 13-meter high in a river bank, where 100-year flood can make the entire river bank in a flood situation. Uh, but in our country, there are states like Himalayan states, northwestern and northeast, where the slopes will be extending to greater heights, more than 20 meter, 30 meter, 50 meter, and even 100 meter. So the Himalayan states like Uttarakhand or Himachal, the slope can be very steep and very high. Then we will be having the challenging slopes in Konkan region, in South Indian the slopes, especially the coastal slopes. The here the height may not be less than the Himalayan situation, but the soil properties are equally complex. So if I'm going to itself in the northeast or northwest, when we move from place to place, we will be again seeing special characteristics. So hence, no guideline or no codes can really the standardize 100% of the characteristics of these slopes, and a ready-made solution which will be applicable for a particular category we will not be able to define, because from place to place the conditions will be differing in terms of the soil strata, in terms of the 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 geological behaviors, the geotechnical characteristics, the lot combinations, it differs. These are photos. I'm sure you may not be able to see that closely, but it is very important when we talk about any slope instability to get maximum visuals. A site visit is required, but nowadays we can get a lot of very good the digital images, and those can be used maximum for understanding deeply about a project. So we can see landslides in Mizoram, landslides in Arunachal Pradesh, landslides in Assam, landslides in Sikkim. Even if they are in adjacent states, in each place some difference is there in the characteristics. So the photos, movies, the digital images, when we are going to a site, maximum we need to collect it. So this is an example of a Himalayan landslide. This is a place called Lembagat in Uttarakhand. Uttarakhand is the Devabhumi, where the nature is at the peak of its beauty. It's definitely, if we move through that place, we will feel that heavenly beauty there. But at the same time, we feel the instability of the mighty Himalayan very much there, because everywhere we will feel that we are walking through an unstable ground. So here, if you are closely watching, we can see a number of slopes. So this may be where my cursor is moving. There are hills, and what we are seeing is a, a river bed which is having a lot of debris lot lying on in the bed. Okay, and again you may be able to see that a road is passing on the one side. The hill is there, and the other side is the riverbank slope. And we can, if we are closely looking, a number of slopes can be seen. And if I describe in terms of the slope stability, I will say that at present from this photo, none of these slopes are stable. And what are the forces, the challenging forces what we are seeing there? First of all, the height is quite high. The height is really quite big. Second, the steepness, the angle of slope, that really makes it unstable. But the most important is, whatever the strata what we are seeing, the rock, that looks falling everywhere. It not looking like a stable rock. Then there is a river bed we are seeing. At present it is a dry condition, but during the monsoon time or even the summertime, when the ice melts or some glacial melting happens, the river body will be going through the top of this slope. Even if in between some beams are there, road itself is acting as a beam, this is in fact a continuous slope, and the river body is going through the top of this slope, which will make the slope toe degradation, which can create a total instability for the slope. Another factor may be the hydraulic forces may be causing scoring. What is scoring? When the water moves, it will make the soil or the strata to get disturbed, and it will carry the soil particles with it, and that can cause the scoring. And if the toe is getting disturbed by the scoring, what can happen? There can be subsidence. The rod which above, that we will suddenly see that it is subsiding, and we will wonder how a hill road can subside, because it is better soil. There will not be that type of consolidation, settlement and all, but still it is subsiding. The reason is, from the toe, the scoring happens. So when we talk about the slope stability here, it's a combination of the parameters which are causing the trouble, and we may have to prioritize the forces which need to be milded first, and where the resistance has to be increased. Then only we will get the desired factor of safety. So when we talk about the landslide scenario of the whole country, it's 22 states and 2 union territory of the country are affected by landslides, although they differ the scale of severity of the disaster. And usually there are several classification, but we can, based on the hazard zoning, we can tell that the Himalayan states are the highest hazard zonation, that is in Himalayas itself. Then maybe the second category may be the northeastern hill ranges, which we can categorize as high, and Western Ghats and Nilgiris, we can tell that the hazard rating moderate to low. So the landslide mitigation works, the last 3-4 years in Lembagad, it was happening, and we will see at the end of this session what are the different measures which are being adopted in the Lembagad and similar type of stretches. Okay. Now I am going to the second terminology which I used in the title of the today's session. That is the rockfall. What is rockfall? Just as the word indicates, when the rocks are suddenly falling. Most of the time under the force of the gravity, we will call it as rockfall. So it is one type of landslide. But many a time when we talk about the landslide, it is like a huge mass is moving gradually or sliding gradually. This is coming to our mind. Is most of the time that may be the picture of a landslide, whereas the rockfall also can create severe slope instabilities, and the difference is this is a type of landslide when rocks used to fall more vertically. It will get detached from its origin, and it will move. It can be a projectile motion, or it can be a vertical motion as per the orientation of the strata, the height of the strata, the slope of the strata, and the size of the rock, the weight of the rock. So the motion can be different, but it will be relative to a normal landslide. The rockfall motion will be more vertical, and many times it can become quite critical. In the case of this case, this is North Front Railway 1 stretch. The rockfall mitigation work is being done, and this is the photograph which is taken before the mitigation methods are adopted. So we can see that if vulnerable rocks are there, definitely that is posing a problem, because the track is very much near to this vulnerable rock face, and any rock which is falling can cause the risky situation for the train as well as the passengers. I talked about the subsidence. Due to the toe erosion, when water bodies are uh, passing through the toe of a slope, this type of subsidence can happen. This is in Uttarakhand. The toe is getting eroded and scored, and due to that, the, uh, the, there is a differential settlement, and the road is getting disturbed. And if we are just doing something at the top of the road, that is not going to help. The stabilization, the slope stabilization need to start from the bottom of the road, or start from the riverbed. When there are very high level of slope instabilities with a lot of uncertainties, that is avalanches. So when the snow is moving like a flood, we call it as avalanches. And there are mitigation methods which can be adopted. The main characteristics of most of the avalanche mitigation systems are, it is preferable to have the materials which are of lightweight to be used for the avalanche mitigation, because like in the case of the seismic activities, the moment we are putting heavyweight material, that can cause or that can trigger more risky situations. Now, one more type of slope instability, that is debris flow. So debris flow is again a water flow, but with a lot of debris, rock fragments, and the energy which it carries will be quite high. When the water comes with the debris, usually it comes with a very big sound. Uh, that energy we can feel with its sound and its movement, and whatever comes in the path of it, this type of debris flow, that will give damage to the all infrastructure or men or animals which is in the path of the debris flow. So this again the photo from Uttarakhand, but the debris flows are common during the monsoon time in many other states. Now, for when we talk about the slope instabilities, how we can utilize the materials as well as the technology for bringing a slope which is unstable to a stable condition. The first and foremost is understand the problem. Okay, so we have already seen that the steep gradients, a steepness of the slope will can trigger a slide problem or a slope instability problem. This will be valid especially when we are comparing the slope which is more than the angle of internal friction of a cohesionless strata. So suppose we are having a strata where cohesiveness is or cohesion is not very dominant and angle of friction is the dominant factor, and if we want to make a slope there which is having more angle of friction, then definitely we all know that that will not be stable. Okay, and if it is a C5 slope where cohesion is there, angle of internal friction is there also we can find out that what can be the safe height or what can be the safe slope. So if the slope is steeper than that safe slope, it can cause an instability. Second, human intervention and sudden increase in overburden or other loads. Okay, so the second villain is we ourselves. The engineering has grown, technology has grown, the most modern softwares are available for the analysis, but still without doing an engineering analysis, we go and cut the hills just doing partial analysis. Okay, so the human intervention without a proper planning and proper engineering analysis can cause the slope instabilities. Unfavorable discontinuity orientation. Many times when we are cutting, when we are opening a hill for a road or a railway track, we may be cutting a slope which is exposing unfavorable discontinuity orientation. So such geological features also can cause the slope instabilities. Climatic changes, frequent floods, cloud bursts, flash flood. So we are seeing that our Mother Earth is subjected to more and more calamities in the recent years, and these type of calamities frequently visiting. Even if the calamity is visiting, that time the slopes are standing very strongly, but the repeated attack, which are cyclic in nature, can cause a slope instability. Continuous rainfall. That continuous I want to underline, because many times we think that very heavy rainfall happens or the rainfall intensity is very high, that time the calamities happens. It may not be. It may not be happening at the time of the highest rainfall intensity. It may be happening when continuously rain happens and without a stop, even if the rainfall intensity is moderate or low. Glacier melting. Okay, so we all know that the global the temperature is going up because of so many reasons. The but the after effect is the glaciers, especially in the glaciers in the upper Himalayas and even the lower Himalayas, sometimes they get melted in the wrong time, and unexpectedly that can come and disturb, that can flood our the river bodies which are tributaries of say our holy rivers, and that can create a lot of instabilities. Finally, the deforestation and seismic activity. This I think we all know from our primary classes. When we do the tree cutting, it will cause erosion, and the continuous erosion, chain erosion, will cause a severe slope instability. And then seismic activity, we all know that the it is the dynamic vibrations whichever it is happening during the seismic events that can make the slope unstable, especially the slopes are not designed, the slopes are designed partially without considering the probable dynamic loading. And destabilizing mechanism, we may have to go into the depth of it, whether we are using innovative material or whether we are using conventional material. Each of the mechanism itself will be having the sub mechanisms. Okay? 6 or 7 failure mechanisms may be, we may be able to define in each of this type of causes. For example, we were talking about the debris flow. So this is a typical the flow diagram of a debris flow event. It starts from the hilltop and it's moving. Okay, the overburden, when it moves the overburden material from the uphill slope, that is moving with water, and it's like the surface runoff and natural channels on the slope surface. The debris flow which has happened here, that has disturbed everything, and finally it is reaching to the small stream in the downstream. So in the whole path, it is disturbing many slopes or many strata. And if we have to protect, it may be a very expensive type of solution. If we start from the top of the hill up to the bottom, that itself may be a 1.5 kilometer. In the photos where I have shown here, there it is ranging between 1.2 to 1.5 kilometer. So it is impossible to spend a lot of money on the whole entire path, but we can do something. The near to the origin of this debris flow, if we can place certain energy dissipation barriers, then definitely the damage whichever this debris flow is making, that will become in control. So our solution is not just doing some lining and protection wall or anything. It will be lining and protection walls are required, but some energy dissipators also may be required. So all together will act as a solution system. Okay. Now, factors triggering the landslide. This is being taken from IRC 15, which is a not a new code or guideline. It is a old state of art report which is published by Indian Road Congress, and the few guidelines which are now coming out and which came out in the last 5 or 6 years, a lot of cross reference we can get from this IRC 15. It is a very beautiful state of art, and in that this type of a flow chart is there which is dividing the different types of factors. So for the slope instabilities, the division is natural factors and anthropogenic factors. We have already talked about this. Anthropogenic factors is deforestation and the improper land use of the people. And when the natural factors, we can categorize as inherent factors and external factors. What are external factors? External factors are seismic forces, rainfall, melting of snow, volcanic eruption, all these are external factors. Whereas the internal factors of the slope, the internal factors of the slope is the type of rock, the geological features, the structure, the slope, the hydrogeological condition, that is the subsurface and surface flows, and the geological condition, fold, all this will come in that. And then finally the geotechnical parameters, the shear parameters, C, phi, the density, the bulk density, everything will come in that. So, and what the IRC-SP 106, IRC-SP 106, this is a relatively a new guideline. New means I think it has come out in 2014. So this is talking about the approach towards the investigation of landslides. Okay. So see, even in the landslides, I mentioned that the slope instabilities in the landslide, it is of higher scale. Okay, compared to a normal small, a 6 meter a slope is slipping, and a 60-meter Himalayan slope is undergoing a landslide. It is quite uh, uncomparable. Okay, but whatever it is, the approach, how in the investigation of the landslide, what should be the approach? So usually we can divide the investigation into two categories. The first is preliminary investigation, and the second category is the detailed field investigation. So preliminary investigation, again we can divide into two. One is desk study. Desk study means by sitting in our own place, how we can study about the a slide which is occurred in a distant place. Okay. So now with all this COVID and doing everything through digital, we can really connect with it. All right. But this is accepted as a the one of the first preliminary approaches when a conceptual scheme we are deriving for the landslide mitigation. So desk study will be the collection of all the informative data, whatever it is possible, maybe from the GIS studies, maybe from the earlier documentation, maybe from the any similar projects which is being carried out in the same place, collection of different thematic maps, aerial photographs, or remote sensing. So all these can bring a lot of information to the designer's table. Second is the designer and his team, they are going to the site and doing the site inspection, surface studies, ground deformation, all this whatever he can do, he is doing by standing in the site. Okay, we will see that why the surface studies, especially the surface movement studies, is very important for a slope instability study. We'll see that. Okay. And then what is the field investigation, detailed field investigation? Before we are arriving at the final solution, we have to do definitely the detailed investigation. Here also surface deformation will come. Okay. Surface deformation will come in the observatory method as well as in the detailed investigation. Subsurface exploration, geophysical investigation, geotechnical and groundwater investigation, or I will say that hydrological investigation, all are important. So one question we used to face in academic, you will not get these type of questions, but when we face the practical engineers, they will always ask a lot of questions, like, oh, whether we should do this many tests, this much research is required, and they will tell that it may be impractical. Even if fund is allocated, this may take a lot of time. So I used to face this type of concerns from the practical engineers, but the answer is that is, even if it takes time, even if it involves money, it's required. All these are required. Maybe we can reduce the information, some of the overlaps we can avoid, and from when we are doing, we can do a sequence, so that some of the understanding once we are getting, we may not repeat in the next investigation, but most of this investigation has to happen. And from the first one, desk study, we will end up with a landslide susceptibility map. From the desk study, from the various photographs, from the various videos, the digital images, we will be able to find out which are the vulnerable areas, which can create problems, okay, and which is important in the point of view of saving men and infrastructure, which need to be protected and stabilized. So the landslide susceptibility map we can find out. The next is the hazard zonation map. Even after the susceptibility, through the site visit, we can clearly define that which is critical, which will cause a hazard, which will cause a risk in the highest level. And risk assessment map, how much risk is there, okay. And once we are seeing that there is high risk is there, then only somebody will go for a detailed investigation. And in the detailed investigation, from the different observations and geophysical, geological, geotechnical and hydrological studies, we will be able to understand that the what can be the deformation mechanism, how much movements can happen, okay, how much movements can happen in addition to all the other type of failure mechanism, like the sliding, overturning, foundation bearing pressures, all this bearing capacity failure, settlement failure, everything can happen. But one is very important, the movements. Then stability assessment need to be done, and finally the mitigation measures need to be designed. So as I told that it is very important to understand the surface deformation and what are the different ways of understanding the surface deformation. So the photography as well as remote sensing as well as the geomorphological and geological maps all will help. But it will be quite helpful if we can employ some type of instrumentation like extensometers or tilt meters. So these can closely see that how much the ground will be having the movement right now, okay, and especially the relative movements in different climates, different conditions, how the relative movements occur, that can be plotted. Another the investigation which need to be done, those are geophysical investigation. So when I talk about in my theme the innovative materials for the landslide and rockfall mitigation, I would like to means clarify that the innovative materials and the technology what I am going to refer, it is mostly the flexible type of systems. Flexible type of systems means something which is after the installation also will free to move, okay, free to move more frequently and it can accommodate a lot of movements. So if it is made of concrete, will it free to move so easily? No, it is a rigid system. If we are using a masonry in or random double masonry in cement mortar, is it free to move? Very little. There will be micro movements in every cells of the universe. There are movements, so there will be. But these type of rigid systems are not supposed to move that much. Its advantage is rigidity, but its disadvantage also, especially where a lot of movements are there. The movements may be caused by the seismicity. The movements may be caused by the biggest cause. I have not mentioned that much in the causes, but the biggest movement cause may be water, subsurface and surface flows. So if the structure is flexible, it can move with the surface or subsurface flow, it can move with the seismic forces, it can move with the lateral deformations to a great extent or a greater extent compared to rigid structures. Definitely there will be a boundary for that also, but it can move to a higher extent, okay. So the all solution systems, the innovative materials or systems which I am going to present, those are of flexible structures. So the investigation time itself, we really have to understand that for the flexible materials, the pattern of mechanism will be different, and we really have to understand that the 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 uh, the whether the materials as well as its installation methods whether that has to be governed by the type of strata which is just we are seeing on the face of the slope, the base of the slope, and the strata below the slope. Okay, so for that we may have to conduct the different types of geotechnical, geological, and geophysical investigation. So what is the what you mean by geophysical investigation? We all are studying the geophysical investigation, especially the popular investigation methods like seismic refraction and electrical resistivity methods. In most of the landslide areas, the seismic refraction and sounding methods are adopted more frequently than electrical resistivity methods. The reason is that the electrical resistivity methods will not give a accurate results when it is passing through, when the electric rays are passing through strata which is having moisture, and the places where the landslides or the rockfall happens, a lot of moisture will be there. So more preferable method of geophysical investigation is to go for the seismic refraction method. And for the seismic refraction method, what are we targeting? So the targets are highlighted here: stratification of subsurface material, profile of the top of the bedrock, depth of groundwater, boundaries of various types of soil deposits, presence and depth of voids, buried pipes, existing foundation. All these are informations we will be getting, not 100% information, but we are getting a good idea by a geophysical investigation. Okay, and why we are, when we can do the geotechnical investigation, why we have to spend money for geophysical investigation? So the reason is that most of the time the slope stability analysis, when we are doing, we need to have a lot of information, especially in places like Himalayas or Konkan, where the properties, the soil properties or the rock properties are changing horizontally as well as the vertical direction. And if we have to bring the geotechnical investigation, we need to do the either the lab studies or the field studies or both. And for that, a lot of sampling is required. The borehole has to extend to a great extent as per the height of the structure or the height of the slope. And the many times in the hilly region, this type of borehole uh, exploration will be quite expensive and difficult. Okay, so we cannot avoid it, we have to do that. But if we are conducting the geophysical investigation and we are able to understand and define that how many profiles are there, how many subsurface strata, different subsurface strata are present, then from that we will be able to reduce the number of boreholes and the number of samples to be collected. So doing a right geophysical investigation will be able to economize the geotechnical investigation later we have to do in most of the cases. Then geomorphological mapping. So this is being again taken from IRC 15, the state of art report which was published in I think 1995. So we can see a lot of information like this, that how someone can do a geomorphological mapping by going to the site. So what it is telling, the if we are seeing say springs or saturated ground in areas not typically wet, if we are identifying in a place suddenly some wetlands which is otherwise dry, that means that there is some movement of the water, maybe the underground water has happened, and that means that already some slide has happened within the strata, and that may be causing further slides. Again, dead trees, if you are seeing suddenly a part of the area is completely green, but some trees are dried up. Okay, So we feel that, okay, what has happened to that tree? All right. Something very sad which has happened, something evil has happened. No, it may be because of some the water has drained out of the cracked ground, some cracking happened, some geological movement has happened, some slide has happened, the ground has cracked and the water loss has happened, and that may be the reason the tree must have dried up. Then again, the existing structures got tilted or the trees got tilted, so those also can identified as a as an indication of the sliding is happening. Then our normal geotechnical investigation, we can do the investigation disturbed by disturbed sampling. We will get all preliminary behavior like soil type or rock type or gradation or consistency, density, all this we can find from the disturbed sampling. But we may require to go for in-depth analysis like the shear characteristics from a triaxial test or compressibility or uh, the in-place strength, all these from undisturbed sampling. Okay. So, in the geotechnical investigation, one major identification is whether it is a soil or whether it is a rock. Okay, so this is fundamental. Again, if we are going for conventional system or innovative system, this knowledge need to come. Okay, and if it is rock, okay, any slope we can cut. That is a very wrong understanding, because sometimes the rock can be quite vulnerable and it can create more problems than the soil. So if we are going for a rock, again rock sampling and rock characteristics are to be collected and identified. And for the soil slope, we already talked about the different types of the test to be conducted, like shear strength, then permeability, the grain size distribution, the densities. So all the normal tests what we are taking for slope stability analysis, that need to be taken even for a landslide or rockfall prone area. But the most important is the hydrological investigation, and that used to get neglected most of the time. The projects which I involved, many of the slope analysis, I used to see that in the whole set of data which is coming from the site, the if we ask about the hydrological data, it's a like a big nil. The normally the people will tell that, oh fine, means and say rainfall intensity, oh you assume it, or what is the infiltration capacity of the soil, you assume it. But it is not a very big challenge. If we are having a will, we can do it. So for the hydrological investigation, the one of the primary data which is required is the annual rainfall and the for a particular time. Okay, so it is ideal to go for a 100-year return period, the like last 100 years, what is the maximum rainfall intensity happened and how much time. So that is one of the most primary data which is required. The average and highest deviation of rainfall as well as the intensity per hour, those are also important. Another important parameter is the catchment, or another important features is the characteristics of the catchment. And for that, first we have to identify the catchment area. So somebody who is going to the site, he has to map the catchment area and understand that the how much is the possibility of the surface flow and subsurface flow, and to differentiate between the two, how much water can go inside the soil, we need to understand the infiltration capacity of the soil. So if we know the gradation of the soil and the slope of the area, the if the mapping involves the contour mapping, then definitely with that we can find out how much the infiltration can happen. And nowadays the drones and such type of tools are available, so it's not a big deal to get the complete catchment area mapping. Now coming to the rock slopes, for different types of analysis is possible. There can be the 2D limit equilibrium analysis as well as the 3D wedge failure analysis, and it all depends on the different types of the rock characteristics. One can decide that what type of an analysis is to be done. So luckily we are having at present good rock mechanics specialists in the country, and many softwares are available. Even if we are not having very deep understanding of the rock mechanics, with our the normal civil engineering branches like geotechnical or geological and hydraulics awareness, one can employ the rock mechanics software, and we can have a good analysis for understanding the slope stability. Okay, so but the common sense for civil engineer, something which always help us is the common sense. So as I mentioned that we don't have to means very much understand deeply that the rock mechanics aspect. Still we can uh, do for a rock slope analysis. Those type of softwares are available if we are having the right observations from the site and the preliminary understanding of what type of a rock and what type of a failure can happen, the common sense, then we can really feed the data in such type of software, understand how the failure mechanism the software is defining from the output what it is giving. So it is a big topic. I am not going to the depth of it. Now coming to if it is a soil slope. So if it is a soil slope also, it may not be as deep as the rock slopes, but even in that case also the different types of the failures can happen. Like for example, so this is a simple slope. Even in this simple slope, we have to see that apart from a global slip, what are the other failure mechanisms which can happen? It can be a base failure, or it can be a toe failure, or it can be a overall failure. So the judgment will be supported by the theoretical analysis. And one particular the the guideline which I will recommend for all of you if we have to understand deeply about the failure mechanisms, that may be the IRC 75, which is describing very deeply about the different types of the failure mechanisms which can happen for the soil slopes as well as for the rock slopes. So now I am coming to jumping actually, okay? Jumping actually for the materials which are available for making the rock slopes, I will not say stable, but protected. Okay. So because many of these materials are not completely stabilizing, but it may be protecting from the deterioration, and in a way it is preventing for a complete uh, uh, deterioration and final a collapse or a destabilization of the slope. So the first one, okay, the first family of the protection work, not stabilization, protection work, I will call it as the simple drapery system. Okay, what is drapery systems? I was hearing Dr. Jimmy was speaking about the different types of erosion control mats. So I will say that these erosion control mats are drapery systems. Okay, the drapery systems are the something which we can drape on the slope surface. Okay, So for a erosion control mat, we will go for lighter and softer and more flexible materials like coir mat, jute mat, or polypropylene mat, uh, or polypropylene mat reinforced with the geogrid or steel mesh. We can go for all these. All these can be used for draping a soil slope. But when it is a rock slope, if we just drape a jute mat, the jute mat get teared or punctured by the sharp edges of the rock. So in that case, we may have to go for even the same for polypropylene, the polymer material or geosynthetic materials. Just if we are making on the top of the rock, it may not work. First of all, it may not hug. For any erosion control material, it has to hug the surface. Because of the different undulation, it will not. Second, why are we keeping the erosion control materials? It is actually facilitating the vegetation growth. Vegetation is stabilizing. Vegetation is preventing the erosion. But in a rock, we won't look for the vegetation to come and stabilize. Most of the time, the vegetation may cause more uh, disturbance. It may cause weathering. Okay, not in all the cases. There are situations where the vegetation can help in the rock slope also. But I was talking very general way. So the coming back to this, the whatever the system I am showing in the simple drapery system, the three images are there. All these are in fact with the steel. Okay. So the steel, there is a covering or a drapery system is shown in the simple drapery system. So that is a steel mesh which is draped the entire surface of the rock. Okay. And in the simple drapery system, there will not be any surface anchoring or pinning. It will be only at the top or maybe at the top and bottom. Okay, so you can see the first one, which in fact the anchors or pins are only at the top, and the rock slope is there, which is fragmented. And if that is not protected, then those fragments can move like a projectile, or it can be slided down and create the problem on the road. Okay, or the railway track, or another infrastructure which is placed here. Maybe here it is a powerhouse or a house is there. So the rock can fall and it can create a problem. But when we are giving the anchoring at the top only, the rock is not getting stopped. Rock will move and it will come up to the bottom. So in that case, the rock is only guided. It is not stopped. The detachment is not stopped, or its falling is not stopped. It is only guiding. Instead of the rock is going like a path which is causing a problem, the drapery system, simple drapery system is guiding it, and it is allowing to either collect at the ditch at the bottom, or it may be at the bottom also we will place some nailing or anchors, so that the whatever the rock is falling, that is getting accumulated at the bottom. So the mesh, whatever we are using, the steel mesh, whatever we are using here should be strengthened at the bottom. Otherwise, the whatever the debris which are getting collected here, or the rock fragments which are getting collected here, after some time, that forces, the static forces which is coming on the steel mesh, that is really going to break the mesh. So we need to reinforce or strengthen the mesh which is at the bottom. Now there are reinforced mesh. So again a steel mesh, but we can see that there are the reinforcing cables which are starting from the top up to the bottom. So this is again guiding the rock, but the chances of the mesh getting ruptured or getting stretched, that will not be here because the mesh is got reinforced with the cable reinforcement. So now the second system, so the entire this drapery system that is mentioned in a publication of BIS, Bureau of Indian Standard, that is ISO IS 17745. So it is the material description and specification is there. Okay. But if you are someone who is totally new to the rockfall mitigation systems, instead of going directly to Bureau of Indian Standard publication, I will recommend you to read a special report which is published by Indian Road Congress, that is Special Report 23. Special Report 23 is the state-of-the-art report which is published by Indian Highway Research Board in 2014. Its name is State of Art Design and Construction of Rockfall Mitigation Systems. So in the rockfall mitigation systems state of art, I think the chapter 2 is describing about the selection of the different systems, and the chapter 3 is describing about the analysis and design of rockfall mitigation systems. So you will get how to do the selection of the system for a particular rock type, whether to anchor at top or whether to anchor at top and bottom, or whether it should be reinforced with the cable reinforcement. All we will find the information from IRC HRB 23. Then there are secured drapery system. Okay, so the first one is a rock surface which is having some instabilities, some degradation of the rock, but there is a rock surface which is highly weathered. A lot of fault points are there. The rock is completely weathered and the frequency of rockfall is so high, then the simple drapery system is not enough. We may have to go for a steel mesh which is pinned and anchored at a number of points. And this, whatever I am talking about, pin or anchor or whatever it is, it's all short nails or short anchor which is having length which is less than say 4 meter. Okay, so it will not be a big deal to do the anchoring or nailing. It will be less than 4 meter, but then the question will be like that, is it stabilizing? Okay, this is not meant for the deep stabilization. Okay, this is meant for only when the vulnerability is at the superficial stretches or the top stretches only is there this type of system will work. The internally it is the rock is geotechnically stable, but the first 1.5 meter maybe it is vulnerable. A lot of discontinuities are there, a lot of weathering has happened. So for that we can go with the simple drapery system and secured drapery system where small nails are there and there is a mesh which is anchored at several points at the top, at the bottom and on the surface. Okay, now I am going for this secured drapery system. In the rockfall mitigation systems, it is classified as the retention system, not retaining wall, retention system. Whereas the first one, simple drapery system, is called as a protection system because it is protecting only, it is not retaining anything. It is not retaining the rock, it is allowing to flow, fall. Whereas the secured drapery system, it is making the rock to stay there. Whatever the forces which is coming, centripetal or centrifugal or whatever it is, whatever the forces which is coming from the rock within this secured drapery system with the small nails and the meshes together, steel meshes together, it will hold it together against that force. So it is a retention system. Okay. Then the third one is rockfall barriers and rockfall embankments. So these are again protection system. This is not preventing, the barriers are not preventing the rock detachment, but it is protecting the infrastructure below it. So the barriers can be made. Barriers can be made by a gabion wall. We can make a gabion barrier. Okay. So gabions are steel wire meshes which are filled with the stones and which can be interconnected with the lacing. So we can construct a gabion retaining wall and in the path of the rockfall, and that will really protect. So it can be done as a self-supporting wall without any backfill, but with a good foundation embedment. This illustration, I will say that it is having a gap because it is not showing any foundation. But if it is in the path of a rock which is having weight, say more than uh, 1 ton or 2 ton, and which can fall with a height of say 30 meter, then the gabion wall will not be able to sustain that if foundation is not there. So definitely a foundation is required when it is getting designed as a self-supported wall. Then here in this case, there is a backfill also is provided for the gabion wall. Then another type of barrier, that is a embankment which is constructed with a reinforced soil structure. Okay. So, reinforced soil structure with the green terramesh fascia. Okay. So, this is a terramesh and all, it is a particular brand name. So, I don't want to go there. So, instead of that, let us use the generic term, that is a reinforced soil system with a vegetated fascia. So I heard Dr. Jimmy was speaking about reinforced soil structure. So we can use the local material there. We can reinforce it with a geograde or steel mesh, and we can give a vegetated fascia, and that can act as a barrier in the path of the rock fall. Then there are steel barriers. Okay, so this is a steel, this is a indicative diagram of a steel barrier. We will see the photos of the steel barriers and all. So if we provide gabion wall or reinforced soil structure and all, it will take a lot of space. But if you don't have the space and we want to place the barrier in the slope itself, so there we can go for a steel barrier. Even for a debris flow, we can use steel barriers. So steel barriers, the 20 years before, when I was first seeing the steel barriers and all, those were very complicated. It was requiring so much ground preparation, embedment depth, and it was quite expensive also. Installation is another big expensive uh, method. But the good news is the last 10 years, the agencies which are acting in the rockfall mitigation and consultants, experts, they worked together to make this type of barriers and all simplified. So now there are very good barriers, very effective barriers, which are having very high energy capacity up to 13,000 kilojoules. Those type of steel barriers with a very simple type of foundation installation, and it can be reused a number of times also. So the fantastic way the research has refined these systems, this type of steel barriers, and a testing methodology is also being developed for these barriers. Okay, so when I'm going back to the old systems of the rockfall, so apart from the static analysis, whatever we have to do, dynamic analysis also has to be done. So compared to the normal type of materials, what we are using in retaining walls, or a normal type of slope protection, for all the systems which are being used for the rockfall mitigation, the additional tests are required. So apart from the tensile strength of the mesh, or the tensile strength of the wire which is forming the mesh, or the elongation, because elongation is giving the flexibility, we need to find out the tensile strength of the mesh panel, the punch strength of the mesh panel, the impact resistance of the mesh panel, or the energy absorption capacity of the mesh panel, again for the if we are using a gabion barrier, the same tensile strength, punch strength, energy absorption capacity. So if each of these tests is described in the different codes I mentioned, like ISO IS 17745, which is written for all type of drapery systems. For the Gabion, there is a BIS code IS 16014 2018. It was first published in 2012, but the addendum which is incorporated the Rockfall netting, that has come in 2018. So it is describing all the different tests which need to be done and the terminologies that is there. Uh, Now, for this is again not, we cannot call it as a new system. The again nailing system is something which was very much in practice in our various mountainous zone, and here the speciality is in the first photograph what you are seeing. So this is done in a project which is in Chennai. It's for a real estate project, Sriram Properties in Chennai. So they were developing a town, real estate town, and there for the retaining wall it was almost 17-meter high, 17-18-meter high. So in everywhere they were not getting enough base width to do a gravity wall or a reinforced soil wall. So they have decided to go for nailing, soil nailing, for because the strata is having some hardness, some strength is there. So they thought of increasing that inherent strength, and the fascia will be provided with the gabion. So the advantage of gabion is that the especially mechanically woven gabion, it can be interconnected with each other. So the entire the gabion will be acting as a continuous monolithic structure, and the anchor points will be through the gabion. So a proper connection can be established, and the fascia is completely free draining. So it will not allow any pore pressure to develop. The water will come out. So another photograph you can see here. Here it is not, gabion is not the fascia. Here the fascia is the nailing and just a steel mesh. Okay. So these are two different cases. In both the cases, there is excavation was not possible. So the nailing is the in situ strength improvement or enhancement with the nailing was the main stabilization technique here. But in one case, the gabion is the fascia, and the next case, the netting, steel netting is the fascia. So in some cases, when we are doing the soil nailing for the slope stabilization and all, we can go for erosion control mat. So you have heard from Jimmy Thomas session, the different types of erosion control mat, coir mat, jute mat, or the polypropylene mat or polypropylene mat reinforced with a steel mesh or geogrid. All these can be done. The guideline which is covering all these products, the conventional coir mat or jute mat up to the three-dimensional mat, the most modern three-dimensional mat or geocell, those are described again in some guidelines. One of the guideline which is covering the details of all these type of system is IRC 56. IRC 56, and there is a MORT specification, Ministry of Road Transport specification. Their session 700 is speaking about the different types of erosion control mats. Session 700, I think the table number 7, if you want, you can note down. Table number 7 is describing about the selection of different types of erosion control mats. For example, if the slope is less than 45-degree, we can go for uh, coir mat or jute mat. 45 to say 55-degree, we can go for a a two-dimensional mat. 55 to 65, we can go for a three-dimensional mat. And greater than 65 degree, then there we have to go for a steel mesh or a geogrid mesh need to be extruded through the erosion control mat. So again, some descriptions are there in MORTH 700 as well as in MORTH that we call it as the highway industry call it as Orange Book. Orange Book 700 and 3100 both are talking about the different types of the slope, whether it is a reinforced soil slope or whether it is a normal free slope, how the erosion control mats or erosion control measures are to be adopted. In some cases, some slopes, whatever we do, the vegetation will not come. It may be looking very greenery, the area. I know certain places in Himachal Pradesh. The slope, the all surrounded places are quite green. But some slopes that will not get green. We can use different types of creepers, different types of herbs or shrubs, but it's the slope will stay like that. Okay, and when we are doing a reinforced soil slope or a free slope, we cannot leave the slope like that because in the next monsoon the erosion will start. So we cannot cut a slope or we cannot extend a valley slope and leave it like that. Okay, either we have to go for a proper retaining wall, and if the proper retaining wall cannot be there and if we want the vegetation there, then we may have to go for why the vegetation is not coming. And in my experience in certain slopes, the vegetation will not come because of some inherent wrong properties of the soil, some negative properties of the soil. Maybe some of the the previous activities happened there, or because of some inherent properties, the soil may be more acidic or more maybe alkalinic, or it doesn't have the some of the elements which is recorded in the soil. So agronomical test may have to be done for certain type of soil to see that what is lacking or whether acidity or alkalinity need to be neutralized. So in those cases, those type of neutralization or addition has to be done, and then we can go for any of the bioengineering methods or erosion control methods. And in some cases, hydroseeding. It may be after the this type of erosion control mat is being provided, we may have to still just planting may not work. We may have to go for hydroseeding. What is hydroseeding? We are applying the seeds with water. Okay, so the hydroseeding is a process. Maybe it is a little more costlier than the normal type of seeding, but it will ensure the quick and thick vegetation growth. I talked about the debris flow barriers. So these are to just to show you that some of these type of barrier system, whatever we have talked, that requires a lot of maintenance. Okay, maintenance doesn't mean that we have to repair the barrier. It may not be like that. Maintenance may be when the capacity of collecting the debris. This is almost 15 years a debris flow barrier in Austria that what, but by 15th year it has come to a stage like that it need to be cleaned. Okay, it has to be removed, then only it can take anything further. Okay, so this the design life was only for some 10 years or anything, but after that another 5 years also it has worked and collected the debris. But if it is to be extended, if it is to be extended, they have to take it out the debris. So one of the aspect when we are going for this type of barriers, this is a steel barrier where ring net, I use the term steel mesh. Okay, steel mesh is having, it is strong, stiffness values are good, then flexibility is there. But ring net is among the whole type of steel meshes which is available in the world, the at present the maximum strength is associated with the ring net. I mentioned the guidelines which are available, like ISO 17745, which is Indianized also. We do have Indian standard is ISO 17745 is there. So the ring net is which is having the maximum strength, maximum stiffness. Okay, so this is being made by that. That is why it is really bent this much. That flexibility is there. It is not ruptured anywhere. So now coming to the reinforced soil, that is again we have seen that we can create certain rockfall embankments with the reinforced soil system. Already Dr. Jimmy Thomas has covered the use of geogrid in reinforced soil system. So I'm not going to the geogrid part of the reinforced soil system. I want to talk about the fascia systems. Okay, so when we are creating a reinforced soil system for a slope instability, especially in an area where a lot of landslides are there, and usually these landslides, most of the time, the first, second, and third cause may be the water. So a lot of surface and subsurface flows are there. If a reinforced soil is provided, in this case, this is in a Himachal NH21, there the reinforced soil of height 12 meter to 31 meter, the height is constructed with the flexible fascia. So what are the fascias are being used? The geogrid is going inside. The fascia is made with the gabion with the integrated tail. Okay. So gabion is a wire mesh box which is filled with the stones, and each the block, when it is connected to the adjacent block, as I mentioned earlier, it will be a totally integrated structure we are getting. And why there is a integrated tail? Integrated tail means each of this box, this is one box. That box is having a side panel, top panel, bottom panel, everything is made with a steel mesh. So that is extended to almost 3 meter inside the soil. And a geogrid is overlapped with this 3 meter, and the length of that geogrid, which is going as the soil reinforcement, that will be having more than or equal to 0.7 times the height of the structure. So for this particular photograph, what you are seeing, it is almost 15-meter high. And suppose if it is 20-meter high, the geogrid which is going will be some 14 meter. Okay, for a 20 meters high structure, so 14-meter high reinforcement is going inside, and then a fascia is made of gabion, and the bottom panel is extended to the soil as a secondary reinforcement. Okay, so the geogrid which is inside the soil is a main reinforcement, but the secondary reinforcement and the fascia is integrated unit. So this is what I was speaking. Okay, so the geogrid part, as Dr. Jimmy has covered, I'm now talking about the design of that part. The main design will be the for a geogrid as the reinforcement. It is usually the rupture and pull out, the internal stability, external stability, sliding, overturning, and bearing pressure like any other retaining structure, and the overall global stability also has to be there. But what is the criteria for the front face? Here this illustration is showing the bottom is a gabion with the integrated tail, and the top will be a green fascia where just a weld mesh and woven mesh and vegetation will come. So what is the criteria for the fascia portion? These are all steel. The fascia is completely steel. So for the any fascia which we are combining for a reinforced soil, the fascia has to be designed for the local stresses which is coming. The main forces, earth pressure, the surcharge load, the seismic load, traffic load, everything will be taken care by the reinforcement which is going inside. But the unbalanced force which is coming at the front face, that will be taken care by the fascia element. So these are some of the other the images of the case studies. This is again Kiratpur in Himachal Pradesh. This is in Jammu and Kashmir. There we can see the given fascia. Okay, this is in South India. I am not supposed to reveal the reveal the name of the structure because there is a confidentiality agreement. But this is a 88-meter high structure. 88-meter high structure. This again to show the slope stability. Of course, this is also a geography reinforced structure, but the slope stability is taken care not only by the geogrid which is going inside, but the steel front fascia which is facilitating the vegetation growth. So we can, these are my last slide. Quickly we can see that this is in BRO, okay, Border Road Organization, which is done in northeastern states. It they have done this protection work. There is a gabion wall for the, you can see that just a road is going. So to the valley side of the road there is a gabion wall, and it is standing on the top of a rock. Okay, so the rock is stable, geotechnically stable, but rock was having a lot of vulnerabilities. So a steel mesh, which is called as a high energy absorption panels, is used as a drapery systems, and nails are given intermediately. You will not be able to see the nailing points, but a lot of surface nails are there. And drainage systems are provided because some seepage was noticed through the rocks. So some subsurface drainage facilities are also being provided. This is another structure. Now from the Himalayas we are in central India. This is Mumbai Pune Road, Mumbai Pune Expressway near Adoshi Tunnel. The client is Maharashtra State Road Development Corporation. So this is during the installation of the rockfall protection drapery system. I mentioned about secure drapery system. It is not preventing the rock detachment. It is not stopping the rock movements, but it is holding the rocks together. So we can see that the steel mesh is being spread, and a lot of small nail points are there. Okay, and I'm not sure whether you can see here steel barriers are provided because some 100-meter to 200-meter the top, lot of trees are there. If we have to spread the mesh everywhere, we have to cut the trees, and it will increase the cost to a greater extent. And why the MSRDC did this in 2014? They did because in the 2015 and 2016 they did because during the monsoon time an accident happened here. By rockfall 4 or 5 people died. Okay, so immediately they had to do the protection work and stabilization. So they did within few months itself almost 40 to 45 crore they had spent for this type of rockfall prevention and protection work, and to establish this type of rockfall barriers. This is another structure. It's a very interesting structure. This is the rockfall protection measures at Sapta Temple, Maharashtra. This is in Nasik. So Nasik, this temple is quite famous. In the June, July months, a lot of pilgrims used to come here. And this hillock, from there, the rocks used to fall. And the temple portions, some of these, the most important part of the temple got damaged, and sometimes the pilgrims who are visiting, they are also were getting affected by this rockfall. So a number of rockfall barriers were being placed at different heights, and the high energy absorption panels, those were placed just above the parikrama path of the temple. In the YouTube, if you are going and if you are typing Saptashringi temple slope protection works, you can get the details of these different systems, the rockfall barriers, what is the capacity of the the rockfall barrier. I'm remembering it is 5,000 kilojoules. The rockfall that can be prevented by these rockfall barriers. So when a rock is falling, the projectile, what can be the projectile path and all. Nowadays there are the different softwares are there which will be helping us to find out what can be the rockfall projectile path and where the rockfall barriers need to be placed, and the with the 5,000 kilojoules whether we can, or 6,000 kilojoules or 7,000 kilojoules barrier has to be selected. So nowadays the different softwares are available and we can do it with the manual calculation also. This is another project here, again a very innovative system. It is a umbrella system. Umbrella system is, it is a combination of the anchors as well as a fascia. We were seeing so far the fascia is different and anchoring is different, but in this case this is combined. It is single product. The fascia and umbrella is a fascia system. It's coming together, and we can do it with the emergency protection work. When a disaster happens, immediately we have to construct a retaining wall of say 300-meter. We can use this type of systems. It's like a umbrella, it can be opened, anchoring will be there, fascia will be there. You may have to fill using the backfill, and it can be used. Its limitations are there. We can go with this type of umbrella system only 5 to 6 meter, and but the advantage is that even it can be used for as a avalanche protection measure. This is in Kedarnath, Uttarakhand. This umbrella system is used for avalanche mitigation. And last, again, it is a Maharashtra, Nagpur. You may be able to see that a lot of vulnerable rocks. Again, a temple. Okay, the top of the temple, these rocks are there, and if it is not protected after some time, it is already, rockfall has created a lot of disturbance, and if it is not protected and stabilized, then definitely one day it will create a very unsafe situation for the temple. That is why they decided to protect and stabilize. Here deep nailings were used. The nails are going very deep, 20-meter, 25-meter and all, and then steel meshes are provided. So definitely the capacity of the steel mesh, the nail length, nail spacing, all has to be designed. So there is a design procedure is there. And the last one is, this is a Himalayan case. It is a hydroelectric power project, Chamoli in Uttarakhand. Here also very deep nails were being used, 20-meter, 25-meter deep nails, and drainage system. The horizontal drains which are extending up to 15-meter, 20-meter and all inserted. And there you can see that the climbers are placing the anchors as well as the high energy absorption panels. So if you want to know the details of all these type of drapery system, high energy absorption panels, steel grid, the simple drapery system and all, look into ISO 17745 and 46 as well as IRC HRB 23. Yeah, this is again the close-up of Vishnugad Pipalkoti hydroelectric project. So the summary for landslide mitigation and multidisciplinary approach is required. It is not just a geotechnical or the geological. It requires hydrological analysis, sometimes rock mechanics analysis, even in with the basic information. But multidisciplinary approaches and multi-specialists are required. Flexible structures are mostly adaptive structures. That is its uh, advantage, especially when places where a lot of movements are there. Rockfall protection, drapery systems and barriers are in use now in India, and the required references and caudal guidelines are available. A lot of case studies are also available. Airdocs or umbrella systems is our emerging emergency system. This umbrella system, whichever I talked, last 5 years, that is getting more and more popular in India. Airdocs is a brand name, so you forget about it. For deep stabilization, deep nails and deep drainage systems shall be used. Micropiles, I have not gone to that, but if very high movements are there, if you are doing just deep nails, horizontal deep nails or fascia systems or solar reinforcement, that may not be enough. We may have to go for some other type of measures like micropiles or beam creation at valley side or shored MSE wall, shored mechanically stabilized earth wall. Those type of systems may be required. Okay, so I'm not claiming that with this flexible type of systems, whatever I described, everything will be stable. No, it maybe means, and say some places this may be the best solution, and in many places that may have to be used with the other systems. Then tunnel portals, we have seen that two tunnel portals while we were seeing the case studies. One is in Mumbai Pune Expressway, it was near to Adoshi Tunnel. Then Vishnughat Pipalkoti hydroelectric system, which I have seen shown the last two slides. Those two are the tunnel portal. Those can also be protected with the such type of flexible systems very effectively. Okay, thank you. I know the time is over, but I'm really happy to give answers to any queries from the participants.
Thank you, ma'am, for your wonderful and informative session. Now the platform is open for all the participants. If anybody like to ask any question, then you can unmute yourself and ask the question.
Ma'am,